Hello student, I am Nitesh Kumar, physics faculty from Resonance. Today I am going to discuss the previous year questions asked by NEET based on topic friction. Okay student. So now this first question, this question was asked in 2014 by AIPMT. So question is what? A system consists of three masses M1, M2 and M3 connected by a string passing over a pulley P. The mass M3 hangs freely and M2 and M1 are on rough horizontal table. Coefficient of friction is mu. The pulley is frictionless and negligible mass. The downward acceleration of M1 in diagram it's given here. This one is I think yeah, it's a mistake, it's okay, it's a typing mistake. So this one is the M1 hangs, here it's a M1 hangs freely and M2 and M3 are on horizontal plane. Okay students, so now look at this, the diagram of this question is given. We have to find the acceleration of this M1 block. Okay, so look at this, I am assuming here the acceleration of this M1 block is A. Now if these all three blocks are connected with a string, if this M1 will move in downward direction, what will happen? These two blocks will also move in this direction with the acceleration A. Okay, now if these two blocks are moving in same direction with the same acceleration, it means we can consider this one is like a system. This one is a system. Okay student, now here due to gravitation it will experience a force in downward direction, which one is M1 into G. Okay, now in upward direction a tension. Now because of this tension on the string, this two block is moving. Okay, now if you are considering this one in the system, the normal applied here, if I am assuming it is a N1 and here it's a N2, the total normal N equal to N1 plus N2, and N1 is what? M2G plus M3G. This is the normal force. It means the both will experience the friction also. So the total friction force experience is mu into N, or what we can write, mu into M1 plus it's a M2 M3. So mu into M2 plus M3 into G. This much of friction the system will experience in this direction. Okay, so now first one by one I am writing equation. First I am writing the equation for this M1 mass. What we can write? M1 into Z minus T is equal to M1 into A. Okay, now we need to find here acceleration. So I am writing here this one in the form of T. So T equal to what? What we can write? M1G minus M1A. This is the T. Okay, now this one is the first equation. Second, if you will write the horizontal balance of force, okay, or F net equal to acceleration, the total horizontal forces are what? T minus friction force. T minus friction force is how much? Mu into M2 plus M3 into G equal to M2 plus M3 into acceleration A. Okay, now what we can write? It's a T equal to T equal to, all the masses are equal to M. So here this one is 2 MA plus 2 mu into M. Okay, now this one is the second equation. Equate first and second. If you will equate, what you will get? Now the first and second, here I am writing after equating it. So first equation is M into G minus M into A is equal to 2MA plus 2M. Oh, G is also here. Yes, this one is came this side. 2M into mu into G. Okay, from here what we have to calculate? A. So how we will calculate? If you are taking this one this side and if you are bringing this one this side, what you will get? 1 m is cancel out because m is in all the equations. So m is cancel out here. So now what we can write? G, okay. So 1 minus mu into G, 2 mu into G divided by this one will this come this side, so it will be 3. This is actually equal to acceleration A. So answer is what? G into 1 minus which one is matching? Look at this here, this. So answer is 3. Okay student, so what I did in this question, first I written equations for this mass, then after written a equation for F equal to mass into acceleration for this one, and because here tension is same in the string is what? Here we are talking about the ideal string, so string is same, that's why the tension here and here is same, we equated it and we got the acceleration. It's again a simple question student. Come to the next question. Next question is what? A block of mass A, a block A of mass m1 rests on a horizontal table. A light string is connected to it, passes over a frictionless pulley at the edge of table, and from its other end another block B of mass m2 is suspended. The coefficient of kinetic friction between the block and the table is mu k. When the block A is sliding on the table, the tension in the string. So the question, look at this, by diagram we are understanding what they are asking in the question. So here we have a one block, okay, and this is the block A which having mass m1. This one is connected with a one string, another block of mass m2 which is hanging here, the block B which is hanging here. Okay, now this system is moving, so I am assuming it's moving in downward direction with acceleration A, so it will move in horizontally leftward direction with the acceleration A. Okay, you have to find the tension in the string, so I am assuming the tension in the string is here T. Okay, so here also the tension will be T. Now look at this, in downward direction this block is experiencing a force because of the mass here, which one is the m2 into G. Now write down the equation for this block. What we can write? m2G minus T equal to m2 into A. Okay, we have to find the tension, it means we can write equation in the form of acceleration. So it's a m2G minus T divided by m2. This one is the first equation. Now second for this block, if you are writing the second equation for this block, T minus here in this direction friction, kinetic friction is mu k into n, or what we can write, mu k into, it's a m1, so m1 into G, because the normal force here is what? Equal to m1 into G. Okay student, so now what we can write here? T minus this friction force, it means we can write mu k into m1 into G is equal to m1 into A. So A equal to, from here what we can write, T minus mu k m1 G divided by m1. This one is the second equation. From first and second, this is a first and second, if you will equate, because the acceleration of both the blocks are same, I am talking about the magnitude. Okay, so it's a same, it means we can equate it. So what we can write, m2G minus T divided by m2 is equal to T minus mu k m1 G divided by m1. What we have to calculate? T, tension. So from here we can easily calculate the tension. So what I am doing the cross product here. So what you will get, m1 m2 G minus m1 into T is equal to, if you will do the cross multiplication here, T into m2 minus mu k m2 m1 into g. Okay, from here what we can write, take t1 this side. So if you are bringing t this side, what you can write, the t equal to, sorry, yes, पहले मैं एक और इक्वेशन लिख देता हूँ, ज़्यादा शॉर्ट करने की जरूरत नहीं है. So what we can write here, देखो t, if you are bringing this one this side, what we can write, m1 plus m2, okay, is equal to, now the left part is what, m1 m2 g, and if you are bringing this one this side, so it will be come with the positive sign. So what we can write here, m1 m2, taking common here, g plus, if this one is coming this side, it will come with the positive sign. So we can write mu k, or g is also associated, so here we can write g this side. Okay, I am writing again. So what we can write here, m1 m2 g 1 plus mu k. Okay, from here the tension equal to, what we can write, the tension equal to m1 m2 g into 1 plus mu k divided by m1 plus m2. So which one is the answer, m1 m2 g, m1 m2 g 1 plus mu k divided by m1 plus m2. So I think here it's matching with second, so this one is the answer. Okay, now come to the next question, student. Next question, a plank with a box on it at on one end is gradually raised about the other end. Okay, as the angle of inclination with the horizontal reaches 30 degree, the box start to slip, and the slip 4 meter down the plank in 4 seconds. The coefficient of static friction and kinetic friction between the box and the plank will be respectively. So look at this, students. Here what is happening, we are gradually increasing this angle. Okay, and what they are telling, at 30 degree it's a start sliding. So at 30 degree if it is a start sliding, look at this, so we increases the angle, and here theta is increasing continuously, but at theta is equal to 30 degree, it starts sliding. It means the block is present here, it starts sliding at this point. It means this is a condition of maximum static friction. Okay, so here in this direction it's experiencing a force mg sin theta, or here in this direction it's a mg cos theta. Friction force in this direction, the friction force is mu into mg cos theta, mu into normal. So normal is what, equal to mg cos theta. Okay, now at the maximum static case, the friction force is actually equal to the core here driving force. It means if you at the 30 degree, if you want to calculate the value of mu, the coefficient of friction, we have to calculate the coefficient of friction, static coefficient of friction. It means from here we can calculate, what we can write, the F is equal to mg sin theta. Okay, now F is what, mu mg cos theta is equal to mg sin theta. Okay, mg cancel out. So from here what we are getting, mu equal to tan theta. Now theta is given, it means it will be 1 by root under 3. 1 by root under 3 is what, it's a 0.57, or approximately what we can write, it's a 0.6. The answer is 0.6 here and we have here. So these two answers are incorrect. Look at this, for calculating the second part, the kinetic friction, one condition is given here. so it slide 4 meter down plank in 4 second. Okay, 4 मीटर ये यहाँ से यहाँ मान लो स्लाइड कर गया in, it slide the 4 meter at t equal to 0. If it is start at t equal to 4 second, this block is reached till this point. So here if you want to calculate what first we have to calculate acceleration of the block. So acceleration we can easily calculate using which formula? S equal to initially it is at rest, it means what we can write, half a into t square. S is for 1 by 2, acceleration we have to calculate, time is given 4 4 ja 16, it's a 8, acceleration equal to 1 by 2. Now you got the acceleration, now we have to calculate the kinetic friction. Okay, we can easily calculate now the kinetic friction because you have a acceleration. So in this direction it experiencing force is mg sin theta. Okay, in this direction the friction force I am assuming it's a mu k into mg cos theta, and the acceleration of this block, that is we already calculated, it's a 1 by 2. Okay, on next page I am solving it. So what is here? Look at this, that in diagram a downward force along the inclined plane which is given mg sin theta. Here in this direction the friction force is given mg cos theta into mu k. Okay, and the acceleration of block is a, which is the 1 by 2. Write down the equation here, mg sin 30 degree because theta is what, 30 degree, at 30 degree it starts sliding with acceleration a. Okay, minus mu k we have to calculate, mg cos 30, okay, first I am writing cos 30, you can directly write the values also, into m into acceleration, that is also given, we calculated 1 by 2. From here what are the m is in every term, so we can cancel out it. Now we have a what, g sin theta, so we can write g by 2 here, minus mu k c cos theta, so what we can write, mu k root under 3 divided by 2 is equal to a, 1 by 2, again 2 is cancel out. From here what we are getting, we have to calculate the mu k. So mu k, if you are bringing this one this side, mu k root under 3 is equal to g minus 1. एक g तो यहाँ पे भी था ना, sorry, g is here also, so it's a g. Now this one, if I am assuming g equal to 10, then what we can write here, the mu k is equal to 10 minus 1 is what, 9, 9 divided by 10 into root under 3 also, 9 by 10 root under 3, so root under 1 by root under 3, it's a 0.57, 9 by 3. Okay, so this will be approximately this will be 0.51. Okay, or what we can write, we have an answer just 0.5, so we can write it's a 0.5. Okay, understand? So the answer is what, look at this here in this question, 0.5. so the first is the answer for this. Okay, now comes to the next question. Wait, yes, next question, question number 4. This question was asked in 2018, NEET 2018. The question is what, which one of the following statement is incorrect? आपको इनकरेक्ट करना, जब भी ऐसे क्वेश्चंस आए आप क्या करोगे, इसे अंडरलाइन कर लोगे, अदरवाइज आप कंफ्यूज हो जाते हो इनकरेक्ट और करेक्ट में. सो नाउ लुक एट दिस, द फर्स्ट इज व्हाट, रोलिंग फ्रिक्शन इज स्मॉलर देन स्लाइडिंग फ्रिक्शन, ये तो सही है, अपने को इनकरेक्ट देखना, ये सही है. नेक्स्ट इज कोएफिशिएंट ऑफ स्लाइडिंग फ्रिक्शन हैज डायमेंशन ऑफ लेंथ, नहीं ये गलत है. द कोएफिशिएंट ऑफ स्लाइडिंग फ्रिक्शन इज डायमेंशन ऑफ लेंथ, कभी नहीं, डायमेंशन होता ही नहीं, डायमेंशन ऑफ लेंथ कैसे हो जाएगा, ये गलत है. नेक्स्ट वन, इसका मतलब अपने को आंसर मिल चुका है, फिर भी पढ़ लेते हैं. नेक्स्ट क्या है, फ्रिक्शनल फोर्स अपोजेस द रिलेटिव मोशन, एकदम सही है, ये करेक्ट है, ये करेक्ट है, ये करेक्ट है. नेक्स्ट क्या है, लिमिटिंग वैल्यू ऑफ स्टैटिक फ्रिक्शन इज डायरेक्टली प्रोपोर्शनल टू द नॉर्मल रिएक्शन, यस इट इज डायरेक्टली प्रोपोर्शनल, तो ये भी सही है. इसका मतलब आंसर क्या अपना, आंसर जो है वो है 2. ओके, थियोरेटिकल क्वेश्चंस था, ठीक है ना, ये सब सारे क्वेश्चंस आने चाहिए आपको. नेक्स्ट है, हाँ This one is the latest question to 2020. Okay, so in 2020, NEET asked a question: calculate the acceleration of block and trolley system shown in figure. The coefficient of kinetic friction between the trolley and the surface is 0.05. Okay, everything is given. Interesting. Again, it's a easy question. It's same like a second question. Okay, so in this question, look at this. You have to find the acceleration. Okay, you have to find the acceleration. Calculate the acceleration. Look at this. This block will experience force in downward direction. How much? M into G. तो आप यहाँ पे क्या लिख सकते हो? 2G या आप चाहो तो 20 न्यूटन लिखो. अच्छी बात है. Now here the tension is in this direction. Tension is here. This direction. It experience a backward force, opposing force, friction force here. Tell me first the normal here. The normal is here 10G, and 10G what we can write? 100 Newton. Okay, if you written here the normal, so you can write here 100 into coefficient of friction is given what? 0.05, or what we can write? It's a 5 Newton. Now write down the equations. First I am writing equation for the 2 kg block. What we can write? 2G or direct 20 लिख लेते हैं. 20 minus T. I am assuming the acceleration of this block is in downward direction, which is A. So it will move in this horizontal rightward direction with the acceleration A. So what we can write? 20 minus T. Look at this. 20 minus T equal to 2 into A. Okay, we have to calculate the acceleration. It means we have to write this equation in the form of tension. What we can write? 20 minus 2A is equal to T. This is our first equation. Now second equation, T minus friction force is how much? 5 is equal to 10 into A. Again we can write from here the T equal to 10 plus 5, sorry 10A plus 5. This one is the second equation. Equate this, because both are equal to, both the equations we have T equal to this much, T equal to this much. It means what we can write? The 20 minus 2A is equal to 10A plus 5. Now bring this one this side and this one this side. So what you will get from here? The 12A is equal to 15, or A equal to what we will get? 15 upon 12, or or what we can write? It's a 5 upon 4. 5 upon 4 is what? 1.25. So answer of acceleration, here it's in SI unit. So answer of acceleration is 1. This is equal to, student. Okay, so answer is what? 1.25 meter per second. So first is answer. Okay, student. So these are the questions. Yes, these are the questions asked by NEET and AIPMT from friction topic in last 10 years. Okay, students. Have a good time. Bye.